Good morning, friends. As in the last period, we have seen the numericals from the topic electromagnetic induction, and in the last period, I have discussed the questions regarding with the induced EMF. Friends, today also we are going to see the numericals from the topic electromagnetic induction, and these numericals are based on the concept of self induction and mutual inductance. Friends, before starting this article or numericals, we should know the two formulas, one for the self inductance and other for the mutual inductance, which we have already studied. So self inductance E is equals to N into di by dt. So where N is a constant and this constant is known as the coefficient of self inductance. And when we are saying about the mutual inductance, so for the mutual inductance, two coils are required. So the formula for the EMF developed in the secondary coil E is equal to M into di by dt, where M is mutual inductance. ES is the EMF developed in the secondary coil. DIP is the electric current developed in the primary divided by the dt. So this formula we have already studied in the theory part. So first you can read the concept of the self inductance and the mutual inductance from the theoretical part and write down the formula. Then you can try to solve the numericals. So friends, let us start the first question. When a current in a coil changes at the rate of 25 ampere per second. So friends, this unit is very important, ampere per second. So ampere stand for the electric current and second stand for the time. So whenever you will read the question, observe the units. So unit will give you the physical quantity which is present in that question. So 25 ampere per second means that is a di upon dt. The voltage induced across it in the 10 volt. Now here if we will read the question 10 volt, so this is the value of EMF will be given 10 volt. Find the flux in the coil. When the flux what is the magnetic flux if the steady current of the 200 milliampere flows through it. So here again the value of current is given. Here you can observe that it is in terms of the milliampere, and we know that 1 milliampere is equal to how many ampere? 10 raised to minus 3 ampere. Okay friends, I am going to read this question once again. So when a current in a coil changes at the rate of 25 ampere per second, find the voltage induced across it is a 10 volt. Find the inductance in the coil. So what we have to find out? We should find out the value of L, inductance. And what is the flux in the steady? What is the flux? Means phi or d phi. You can write the change in the flux or phi. In the magnetic, what is the flux if the steady current of the 200 milliampere will flow through it? So two values are asked here. So in the second we should find out the flux. Okay, so I hope you have understood this question. Now first we'll write down the given information. So given information says that di by dt, change in the electric current. So di by dt is how much? 25 ampere per second, as I have told you while reading the question. EMF E is equals to 10 volt, and the electric current I, how much? 200 milliampere. Now milliampere will be get converted into the ampere. So 1 milliampere means 10 raised to minus 3 ampere. So here 20 milliampere is there. So we have 200 milliampere is there. So 200 multiplied by 10 raised to minus 3. So further it is simplified there. That the two zeros will be get cancelled out. So power of will be reduced by the minus 2. So 2 into 10 raised to minus 1 ampere. So it will be the simplified value. What you have to find out? The inductance L and the magnetic flux phi. So this is the given information, right? Now we'll go to the solution. Now here I have given the complete solution so that you will understood the question as well as the answer. So here, as per the question, di upon dt is equals to 25 ampere per second. EMF is the 10 volt and the electric current is the 2 into 10 raised to minus 1 ampere. What we have to find out? We should find out the value of L as well as the value of phi. Now we'll use a mathematical formula. The induced EMF is given as EMF E is equals to L multiplied by di by dt. What is the value of E? The value of E is a 10 volt, so that we substituted here. L we have to calculate, and di by dt. So di by dt is how much? 25 ampere per second. So 25 will be given here. So we can further solve. L is equals to 10 upon 25. So you can divide 5 2s are 10, 5 5s are 25. So 2 upon 5, that is nothing but the 0.4 Henry. So remember, Henry is a SI unit for the self inductance. So we have got the answer for the first, that the self inductance will be 0.4 Henry. Now second thing which we have to calculate, that is the magnetic flux. So what is the formula for the flux here? Flux phi is equals to L into I. Friends, remember, lots of students will use the same value of the electric current. So there is possibility that they may use the value of the 25, but remember, here the second current is given and that is the 200 milliampere. So for the second value we should use the 200. So 200 milliampere we have already converted, and we have got the 2 into 10 power minus 1. So the flux with the phi is equals to L into I. What is value of L? 0.4. What is the value of I? 2 into 10 power minus 1. So you can do the multiplication. 0.8 into 10 raised to minus 1. So you can shift the power. So you can write phi is equals to 8 into 10 raised to minus 2 wave. Friends, while solving the numericals, never forget to write the units. Magnetic flux phi has the unit as a Weber. So this is a overall look of the first question. So here we have used the mathematical formula. E is equals to L into di by dt. Then after substituting, we have got the value of L, that is a 0.4 Henry. Then the magnetic flux can be calculated by using the formula phi is equals to L into I, and based on that we have got the value of phi. So here we have completed our first question. Now we'll move to the second question. The second question says that a current is changing at the rate of 5 ampere per second in one coil. So ampere per second means di upon dt will be given there. In one coil induces the EMF of the 4 volt in the neighboring coil. Then the coefficient of mutual inductance. So friends, here current is flowing through the first coil and the EMF is developed in the secondary. So EMF of the secondary is given, that is a 4 volt. So here if you will observe the question, so you can get that the di by dt is 5 ampere per second, and the EMF developed in the secondary, that's a 4 volt. Then we have to find out the mutual inductance. So in the theoretical part we have studied about the mutual inductance. So what does the mutual inductance says? When an electric current will pass through the primary coil, then the EMF is developed in the secondary. For the self inductance, single coil is required. For mutual inductance, 2 coils are required. So that concept we have studied in the theoretical part. So here di by dt is given and we should find out the EMF developed in the secondary. Now we'll go to the solution of this question. So it is a very simple question. So if you have understood the first question, then it will be very easy for you to understood the second question. So EMF developed in the secondary coil. So if someone have the confusion regarding with the concept of the mutual inductance, so here I am going to draw a simple rough diagram. so that you can get the idea. So here EMF is developed in the secondary, that is the ES, and the current is flowing through the primary coil. So IP is a current flowing through the primary coil. So this is a primary coil. Current is passing through the primary. And the EMF is developed in the secondary. And for the mutual inductance, EM is a constant. Right. So that part we have studied in the theory. So the same thing will be applied here. So EMF developed in the secondary coil have the formula ES is equals to M into dip by dt. Now we are interested to calculate the value of M. M is equals to ES upon dip by dt. So EMF is a 4 and dip by dt is a 5. So 5 adds a 40, so 0.8 Henry, that is answer. Friends, remember, lots of time if the time is not given, so time is separately given 1 second or 2 seconds, at that time you should find out the ratio of the di by dt separately. Here the ampere per second already is unit given, means by dividing the time they have given here. So in short, again I am going to read this solution. So here EMF developed in the secondary coil is 4 volt and the current flowing in the primary coil is a 5 ampere per second. So based on that we have to find out the value of EM. So EMF developed in the secondary have the formula ES is equals to M into dip by dt, then M is equals to ES upon dip by dt. EMF developed is a 4, dip by dt is nothing but the 5. So 4 divided by 5, we have got the 0.8. H stands for the Henry. Henry is the SI unit. In the theory part, we have studied that the SI unit for the self inductance and mutual inductance is the same, that is the Henry. So I hope you have understood the first and the second question. First question we have seen regarding with the self inductance, and the second question we have seen that is about the mutual inductance. So we have completed the two questions. Now we'll move to the third question. Friends, remember, if you have any kind of doubt, first you can write down the question and then note down the given information. Try to apply the formula, you will get the solution. Here if you are feeling any kind of the doubt, then you can note down the total solution first and then you can read the answer. Now here we are going for the next question. The next question says that the coefficient of mutual inductance is a 4 Henry. So now the value of M is given. Reading the question will give us the detailed information, and once we get the detailed information, then we can try to apply the formula which we have studied in the theory. The coefficient of mutual inductance means the M is a symbol for it, and that is given 4 Henry, 4H, right? Between the primary and the secondary of an inductance coil, calculate the induced EMF if a current of 4 ampere is cut off in 1 upon 4000 second. So here if a current of 4 ampere, so here I is given and the time is separately given. In the previous question you can observe that the unit was ampere per second. So here separate ampere is given and the separate time is given. So we can divide the di by dt, then we will get the value. So ampere is differently given and the time is separately given. Here mutual inductance is given, and what we have to calculate, they have asked us to calculate the induced EMF. So E is equals to M into di by dt when we are using the formula. Remember, EMF you have to calculate, M is given, di is given and dt is given. So di and dt we should divide so that we can get the value of di by dt, then we can try to apply the formula. Now we'll move to the solution of this question. So as I have told you here, So you can observe that the M have the value 4H is a 4 Henry, di electric current is a 4 ampere, and dt have the value as a 1 upon 4000. What we have to calculate? We have to calculate the induced EMF. What is the formula for the EMF developed due to the mutual inductance? We have EMF E is equals to M into di by dt. So all the values are given. So what is the value of M? 4. What is the value of di? 4. What is the value of dt? 1 upon 4000. Now this 1 upon 4000, when it will be goes to the numerator, then it will becomes 4000 upon 1, right? So finally we can write here 4 multiplied by 4 multiplied by 4000, and if we do the multiplication, we are getting the 64,000. Now this 64,000 we can write in the decimal format, that is a 6.4 into 10 raised to 4 volts. Friends, here we have calculated the EMF produced in the secondary coil. So here we have used the mathematical formula E is equals to M into di by dt. Based on that, we have got the final answer. So I hope you understood this solution. Again, in short, I am going to explain here mathematical part. By using the formula E is equals to M into di by dt, we have substituted the value M as a 4, di as a 4, and dt 1 upon 4000. When it will goes to the numerator, 4 multiplied by 4 multiplied by 4000, we have got 64,000, and that will be written in the power of 10. So we have got 6.4 into 10 power 4. Remember, we should write the unit as a volt. Here volt C is given. So as we have studied, there is a printing mistake will be there. So units can never be written in the plural form. So here you can do the correction that you should write only volt, not holds. Okay. So here we have completed our third question. Now we'll move to the next question. That's the question number 4. Friends, question number 4 is some interesting question. So, and it is one kind of the challenging question. So it first, second, third, these are the plain questions. But question number 4 is a little bit challenging question. So why it is a challenging question? Because here we will not get the answer directly. Here you have to think a little bit. Okay, now we'll read the question. The question says, what must be the primary current? What must be the primary current means value of IP. What must be the value of the primary current so that the flux is a 0.32 developed in the secondary. So flux phi is a 0.32 wave. So flux of 0.32 wave is developed in the secondary. If the mutual inductance is 200, so mutual inductance have the symbol M. M is equal to 200 millihenry. So millihenry we should convert in terms of the henry by multiplying with the 10 raised to minus 3. If this current reduces by 40% in 5 millisecond. Now millisecond again we should convert in terms of the second by multiplying with the 10 raised to minus 3. What voltage is induced across the secondary? So voltage developed in the secondary we have to calculate. So friends, so first we'll write down the given information. So question says phi magnetic flux is 0.32 wave. Mutual inductance 200 millihenry. So millihenry is converted in terms of the henry by multiplying with the 10 raised to minus 3. So 200 into 10 raised to minus 3 henry. So two zeros will be get cancelled and we are getting 2 into 10 power minus 1 henry. Again here dt, time is given. Time is not in terms of the second. So it will be in terms of milliseconds. So dt is equals to 5 millisecond means 5 into 10 power minus 3 second. So again what we have to calculate? What must be the primary current? So primary current means I1 we have to calculate, or you can write the symbol IP, primary current, and if the current reduces by 40%, if this primary current will be got reduced by 40% in how much duration? In the period of 5 milliseconds, what is the voltage induced across the secondary? So voltage across the secondary means ES we have to calculate. Okay, so someone can use this word reduction in 40%. So 40% will be reduced. Suppose 100% is the current, if 40% is reduced, so remaining is the 60%. म्हणजे टोटल करंट 100 आहे, त्याच्यामध्ये 40% तो कमी होत असेल तर राहिलेला करंट किती असेल? 60% असेल. सो इफ 40% विल बी रिड्यूस्ड, so remaining current with the 60%. That logic you should know when you are reading the question. Okay, so it is a little bit challenging, you can't get the answer directly, so we have to think out here. Okay, so we'll use the first formula. The flux is given as phi is equals to m into I. Okay, so here I1 is equals to, so flux phi is equals to m into I. So I1, so our first aim is to calculate the value of electric current flowing through the primary coil. So 0.32 upon 2 into 10 power minus 1. It will goes to the numerator, so it will becomes 3.2 divided by 2. So electric current in the primary I1 we have got the 1.6 ampere. 1.6 ampere. Okay, so again I am going to explain the initial part here. So phi is equals to m into I. So I1 is equals to 0.32 upon 2 into 10 raised to minus 1. After solving this, we are getting the electric current as a 1.6 ampere. Now the question says the current is reduced by 40% in the period of 5 milliampere, in 5 millisecond. So phi in from 5 millisecond can be converted as a phi into 10 raised to minus 3. Now value of I2, current in the secondary reduces by 40%. So reduces by 40% means remaining is 60%. So I2 is equals to 60% of I1. So as it is 60%, 60% means 60 upon 100. You can observe this step that here we have taken 60 upon 100 divided by multiplied by I1. So 0 0 will be get cancelled. So we are getting as a I2 is equals to 0.6 I1. 0.6 into I1. So this is the value of I2. Now the EMF induced is given by the formula EMF E is equals to m into di by dt. So this EMF developed in the secondary coil we have to calculate. So E is equals to m into di by dt. So di means the change in the electric current. So here E is equals to EMF E is equals to m, what is the value of m? Mutual inductance 2 into 10 raised to minus 1. Then I1 as it is, then I2 0.6 I1, then divided by time 5 into 10 power minus 3. So 2 into, here you will observe that the 1 minus 0.6, 1.0 minus 0.6, so 0.4, right? So that subtraction will be done here. So 2 into 0.4 into 10 raised to 2. So how does this 10 raised to 2 comes? So here you will observe that the 10 raised to minus 1 is there, and this minus 3 will be goes to the plus. So 10 raised to minus 2. So here you can observe that the 10 power will be got collected 10 raised to minus 1 multiplied by 10 raised to plus 3. So that will becomes 10 raised to 2. So that power will be written here, 10 power minus 10 raised to 10 power plus 2. So 2 into 0.4 I1 into 10 power 2 divided by 5. So if in the next step what we have done, we have substituted the value of I1. What is the value of I1? 1.6 ampere. So 2 multiplied by 0.4 multiplied by 1.6 multiplied by 10 raised to 2 upon 5. So if we'll divide, we are getting the final answer as a 0.256 into 10 raised to 2. So if we'll multiply further, we can get the answer as a 25.6 volt. Friends, again I am going to explain this concept. In this question, first we have to calculate the value of I, that is phi is equal to m into I. So I is equal to phi upon m, so 0.32 upon 2 into 10 raised to minus 1. Based on that, 3.2 upon 2, we have got the value of electric current as a 1.6 ampere. Then the current is reduced by 40%. So as it is reduced by the 40%, means 60% is remaining during the time interval of 5 into 10 raised to minus 3 seconds. So I2 is equal to 60% of I1. So I2 is equal to 0.6 I1. Then we will use the formula EMF E is equal to m into di by dt. So m into I1 minus I2. Suppose if someone is taking the I2 minus I1, then there will be the no change, only he will get the negative sign here. Then you can take out the modulus sign for the final answer. So here I1 minus 0.6 I1, so subtraction will get this 2 into 0.4 I1 into 10 raised to 2 upon 5. After substituting the value of I1, we'll get the final equation 2 into 0.4 into 1.6 into 10 raised to 2 upon 5, and after solving we are getting as a 0.256 into 10 power 2. So EMF developed is equal to 25.6 volts. So friends, today we have completed the numericals based on the mathematical formula of self inductance and mutual inductance. I hope you understood these questions. Write the questions with their proper solution and don't forget to write the units for the final answer. Thank you. Have a nice day.